Section 4.5, page 4. A spherical shell of chocolate has an inner radius of 2 inches and a thickness of a 1/16 of an inch. We're going to use differentials to estimate the volume of the chocolate. Compare this with the actual volume of the chocolate. So what's happening is we have this shell of chocolate, so a sphere of chocolate, but it's hollow on the inside. If any of you have heard of the Nestle Wonder Balls, this is a beautiful example for that. So this is all chocolate out here. And the inside radius is 2 inches, and the thickness of that chocolate is 1/16 inch. Alright, so one of the things we can see right off the bat is that the change in radius from inside to outside is 1/16 of an inch. That change in radius, delta R, is also dr. We're going to use that in a couple of minutes. We want to estimate the volume of chocolate, so we want to estimate what's the change in volume from the inside to volume to the outside. And that will be the amount of chocolate. And since we're estimating, we don't want you to find the actual volume, we want you to find dV. Delta V is the actual change in volume. From the inside to the outside. Alright, so we need to know volume of a sphere, and volume of a sphere is 4/3 pi r cubed, and we are wanting to find dV, so let's do a derivative here and use the notation dV dr like dy dx. So dV over dr equals, let's do the derivative here, this constant multiple comes down. The derivative of r cubed is 3r squared. Simplify, and we'll have 4 pi r squared. We are wanting to find dV, so let's multiply by dr. dV is 4 pi r squared dr. And substitute in the information that we know. Original radius was 2. Change in radius is 1/16. And when we simplify, 4 times 4 is 16, cancels out with that. Just pi. So change in volume, that's D is the change in, and the little d is estimated change in volume, and inches cubed. So the estimated change in volume, which is the amount of chocolate, is pi inches cubed. Alright, let's go and let's find then the actual amount of chocolate. So actual change in volume, and that's going to be the volume at the outside measurement, which is 2 1/16, minus the volume at 2. Let's see, 4/3 pi times, I'm going to change this to an improper fraction, 33 over 16 minus, that's 4/3 pi r cubed minus 4/3 pi times 2 cubed. And when you zap this into your calculator, you will get 1.032 pi, which when you multiply that out is 3.240 inches cubed. That's volume. 3.240, close to pi? Sure is.